Okay, I think that we can start. Hi guys, nice to meet you again, and I think that we can start with today's webinar. Before we get started, just a few information about how you can interact with us in today's webinar. Note that the audio portion will stream through your PC or laptop speakers, and so be sure to check that your speakers is turned on and that the volume, of course, is good. And if you do have some questions, please write in the chat box. So of course, your mics are unmute, and so you can interact with us by the chat box. Feel free to write whatever you need. The webinar will be recorded, so don't worry if you arrive later or if you lost some part, because after the webinar you will receive the record of the event by email. We are at your full disposal for questions, doubt, and we will leave some times at the end for Q&A session. So we will try to get back to all your questions. In case we might not be able to reply to all your questions, please don't worry, but we will do at our most to follow up afterwards. So I think that we can jump immediately in today's case. I hope that all of you are doing well today, and welcome and thanks to join us. There are a lot of people today, so thank you very much for joining us. My name is Giorgia, and I am the Worldwide Sales Manager at Jexcel. And Jexcel is a company who is in the global market of 3D technology solutions since more than 10 years. I am pretty excited to introduce today's guest, Daniel Ganks from Geolink 3D. Daniel, can you please... Okay, follow us. Fantastic. Hi, Daniel. How are you today?
Hello, Giorgia. Nice to meet you, and I'm really glad to be with here. Thank you for the opportunity to share this event with me, and welcome to all the attendees.
Thanks a lot, Daniel. And I'm pretty happy because today we will experience together with Daniel some cool works in construction and engineering application. But before we get started, let's have a look in today's agenda. So for each case, we will try to focus on the needs and the goals. And we will try also to go deeper inside which kind of technology we have been used, and also the workflow that I think is mainly interesting to know what comes after the on-site activity. And of course, apart from the workflow, we will try also to go inside the result, okay? So Daniel will try to give you a complete experience of this success case from the on-site acquisition up to deliverables that has been created. We would like also to present a special proposal that we have done for you for Christmas. And then we will have time for a Q&A session. So just go straight in our today's presentation. I would spend very few words about who Jexcel is. If you never met us before, Jexcel is involved in the 3D in the global market of 3D surveying and 3D mapping for more than 10 years by developing and providing innovative point cloud processing software and the survey system. We are based in Italy. And Daniel, you are up. Would you please introduce yourself and your company?
Thank you, Giorgia. Our company, we founded 10 years ago. Two of us started with providing laser scanning service, and our path is a bit different because anytime we say a company who does or provides laser scanning, usually they come from one of the engineering disciplines, like an architect company starts doing laser scanning for our own purposes, or MAP, or cyber engineering, and so and on. Our path was completely the opposite. So we started as laser scanning providers, and soon we started to open new directions. We have 4 departments now. We work on the field of classical topography and geodesy. we work with the BIM modeling, and the good thing is that we have the expertise for both of these fields, and it's also a good opportunity to find and exploit the synergies that all these connections can give us. So the projects I brought you today are gonna be just kind of some appetizer. We all put these things together. What can we achieve? A company consists after 10 years now 35 colleagues. We have a very young team, very let's say, we used to say young people have the hunger for the knowledge, hunger to achieve new things, and that's something we really appreciate and really love to have inside our company. Like I said, one of our main pillars now is the classic geodesy. I think each of us, whoever worked with a laser scanner around the construction field, knows that really laser scanning cannot exist without the tools and the knowledge of geodesy. So if you provide laser scanning, you have some knowledge of geodesy, but if you have the people and the instrument park for geodesy, you can do the rest of the services you can offer. And that's where a good synergy point is, because we also have a department for BIM modeling. So we work together with the big German car manufacturers present in Hungary, which means pretty much all of them: BMW, Mercedes, Audi, Volkswagen Group. And when you have the geodesy and the BIM modeling, you already did the first step. From BIM to field to BIM, you have the laser scanner too to provide the instruments for them. Next slide, please. We also opened our architectural design bureau. So using our tools, we do the survey plans, because that's quite something obvious when you provide surveys with laser scanner. But we went one step further. So now we can, let's say, cover the whole progress within the architecture. And we have the last and obviously most important and most interesting department, because that is mine personally, the measurement. So our aim is to be able to provide measurement and quality control services on the ground, in the air, in the water. Let's say, not just providing the service, providing the solution. So whenever someone calls us, we need something measured, then I want to say them, okay, we know how. And on the left, you can see maritime port construction in the River Danube. On the edge of the corner, that's our remote control autonomous bathymetric survey boat. We do the laser scanning. We work with Leica instruments, Faro instruments, but we also work with UAV, because photogrammetry and aerial LiDAR is something which really fits into the geodesy, and also combines well with bathymetric surveys, also combines well with terrestrial laser scanning surveys. And maybe the most interesting and the biggest project of the previous year, on the top right corner, we have our laser tracker, and you can see one of the elements for the new athletic stadium for Budapest, where we provided the quality control for each manufactured piece fitted and constructed on the site. So each of these more than 10-ton steel elements had to be within 2 millimeters absolute tolerance, and the whole athletic stadium fitted like within 2 centimeters of the planned state and the as-built, which is something really even we did not think that it is possible to achieve.
Thanks, Daniel. And I like pretty much what you said, because you talk about solution, and I think that this is the core of 3D scanning, because we are not talking about hardware, we are not talking about software, but we are talking about solution. And I think that this is what people is looking for. So thanks a lot for this complete scenario and introduction of your company. And what is nice is that we have started to work together, Jaxel and Geolink 3D, 9 years ago. It was November, I remember that. And so, I mean, now we can say that we are elder, but better, of course, respect 9 years ago. Well, guys, just now jump to the first case. So the tank cylinder inspection. I think that everyone who works in this application field want to find a way to make the tank inspection process more efficient. So mainly people are looking for something which is faster, with high accuracy, low manpower. And I think that these are three of the main aims that the surveyor chases. So Daniel, can you please introduce where we are?
Yes, there are two things in respect to what you said. Like you said, we have a long relationship behind us, and the best relationships are aging like a good red wine. So this is what our aim is for the future as well. And also in respect for the flexibility and solutions. Like you said, and like I mentioned, in the previous slides, you could see lots of instruments. We have been already talking about quite a few different cases. And whenever a company is such divided in its activities, the tools, let it be hardware and software you are looking for to have within your portfolio is the Swiss knife. So within one tool, the most flexibility you can have. If you have a software, you want to use it on the most application fields you can cover. And this is the point where we are here, because Reconstructor is something which, let's say, whenever we are talking about laser scanning, bathymetry, UAV, on some point of the project, we will get into Reconstructor, because the tools it have, it's not like a pipeline. You can consider it as a pipeline to provide solution from start to end, but you can consider it as a Swiss knife or Lego brick. So it has elements that you can get used in any projects nearly whenever you get in cross with this kind of instrumentations. So let's going back to this project. On the first image, we can see a steel tank. So this is a tank of somewhat 20,000 cubic meters, so quite a big one. This is located within one of Hungary's main petrochemical plants. And we get contracted by the tanks constructor in this site, because whenever this kind of tanks or pretty much any other thing in the construction industry is getting built, we need some kind of geometric control, either because it is part of the documentation which should be handed over to the contractor to certify we built this within this kind of tolerances, or maybe within the construction phase we need to check if there are any kind of deviations from the geometries. Let's consider that these steel tanks were built from metal slices, nearly 6 meters length and 1.5 meters height. It's a huge steel pieces treated with the heat of welding. The thermal changes externally were high because we were in the summer within a front from Africa, 40 degrees outside, then an Arctic one, 15 degrees. And this is changing during the construction. So pretty much the main question was, what do we have here? And if you can imagine this complex kind of surfaces, you cannot measure with the tape, with the disto, not even with the total station, because the shape of the cylinder changes from meter to meter, considering it's welded together from hundreds of little pieces. So this is our main goal. Next, please, Georgia.
Yeah, and Can you also describe a while, because we have already anticipated the need and goal, but can you describe a while which kind of technology did you use and why did you choose that kind of technology? Because you mentioned that you, of course, you apply different kind of technology, and this is also what I like, the integration of different technology. Can you explain a little bit more which kind of technology did you use and why?
Exactly. So this project, a portfolio to cover this the best is a terrestrial laser scanner. So this particular project, we took our Faro S150, which is quite a commonly used instrument on the market, and captured all the inside of the surface. We did like 20 scans inside. It was a two-level structure because in this kind of tanks there is a floating panel inside, which is also important because we must check if on the cylinder surface there is something which could interact with this floating panel, which can go up and down. So that's something like a red flag in this case of projects. And in the end, what we have to extract and provide from this kind of project is the deviation from the planned surface. So whenever this kind of instruments are constructed, we got the 2D plans, we know where the tank should be situated within the facility, we know where the cylindrical surface should be. So pretty much what we have to achieve is put the planned data and the as-built data together, one on top of each other, and extract the geometry deviation data the best visual way, because in this kind of surface, even if you measure the surface like every 2 per 2 meters horizontally and vertically, you will not get the whole image. You just get a few extractions, but the general image you will not have. And this is the point where Reconstructor came in for us. Like I said, we have the data from the laser scanner registered within Faro scene. Even with Reconstructor, we could do the registration. That's something a user's choice. We also have the CAD data. So from the CAD data, we can create a reference model, which is a 3D surface. And Reconstructor has got a tool which we really love to use. It's called inspection, which works between point cloud and point cloud. But our main use is to compare a CAD model, the theoric one, compared to the as-built point cloud. The theory we can always extract from the CAD plans. The as-built state is to be captured with the instruments like laser scanner, UAV, and so on.
So we can say that, of course, we do have a lot of integration in terms of data and CAD. So you have already a little bit explained how did you work. So you register the scan in scene, and then you import directly the scan inside Reconstructor. I think that, can you just quickly resume the main workflow, because I think that this is the main interesting things. Of course, it's clear that you have moved from scene to Reconstructor. It is also clear that also Reconstructor can align the data, but I would jump on this because I think that people would be pretty interested in knowing more about this deviation map. So how did you get this map, and yeah, how did you get this map, and then also how did you use this colorization map out from Reconstructor?
Exactly. So the thing that you already mentioned, but I would like to press a bit more on this, that from any kind of laser scanning software, let we talk about Faro scene, shall we use Leica instrumentation, or maybe it could be even Topcon or Eagle or whatever manufacturer we have, we can get our data seamlessly into Reconstructor. And from the other side, all the engineering companies work with some kind of CAD software. The basics are AutoCAD, or in our case, it's Bentley MicroStation, no difference really at all. The data we have in AutoCAD, we also have to find a way to migrate into Reconstructor as a common platform. So we have the point cloud exported from Faro scene, and we have the cylindrical as planned model from CAD, all put within Reconstructor. The inspection tool from Reconstructor works like that. When you have a mesh and a point cloud, it can analyze and calculate the distance for each point. This dataset consisted like 160 million points from the laser scanner. Each point can be calculated according to its distance from the S-plane state, or if you choose otherwise, because it has some tweaks and twitches within, it can calculate distances along axes, x, y, or z, or it can be absolute values, sine values, so you get quite a flexibility, let's say. And when you have it, it looks like this color map on the top, or first phase, it's gonna be getting a point cloud, but with the deviation color. What we really love is the color scale, which can be adjusted and tweaked however we like. So if we say that we have to stay within 10 centimeters out and 10 centimeters inside, we switch the color scale accordingly to see how are the deviations distributed along the cylindrical surfaces. Or if the contractor calls us 2 days later that, okay, I understand this, but I have 5 centimeters plus and 5 centimeters minus tolerance. Everything which is inside, we do not care at all. Please show me the sides and the places where the tank cylinder is outside of the tolerance. The color scale can be switched in 2 minutes, and in a half hour, your contractor will have the report in its email box. So the point cloud, it's quite easy to provide like this, which already is an interesting thing because these days, as the usage of point clouds gets more and more common, you can just send it over within a Recap or any free viewer format, and that's also a result. But if you want to provide like a classical way of deliverable 2D format, a PDF, you can find a way within Reconstructor to unwrap this cylindrical surface. So Reconstructor has some really nice tool to provide an orthophoto, the classic way, or can be a spherical orthophoto as well, or can be a cylindrical one, which then you can project onto the 2D plane. Then on the left, you can see the parameters that we use to switch and tweak to get a properly positioned and sized cylindrical camera, which helped us to unwrap this whole point clouds into 2D. So on the top right corner, you can see the same point cloud, but now ironed onto a 2D PDF. These orthophotos, then you can just nearly with one click export back into AutoCAD. So Reconstructor offers a possibility not just to export a plain JPEG or PNG file, but with an AutoCAD script exported together with the image file, you can just drag and drop it within the DVG, and you have all your orthophoto properly positioned and scaled. So you can just underlay it within all your CAD data you have in 2D from the side, and there you go. You have the PDF. You just press the send email button, and your contractor has got the deliverable data.
Thanks a lot, Daniel. And I think that you have already, of course, anticipated something that is common between all the projects. So the possibility to create this colorization map. In this specific case, as you mentioned, there's the possibility to unwrap the cylindrical surface. And what is nice is also that you can directly move this orthographic view inside AutoCAD with a direct exportation. So this is just the resuming of the result. Let's jump to the next example that I think is also, I mean, while we are moving into the other success case, I think that also we are reaching out more complexity, we can say, because we will see that Daniel has used a different device and different software. Also, the goals are different. So, Daniel, can you just quickly give some details on the building that you have analyzed? Just briefly, some details, please.
Okay, our next topic is also somewhat inspection related, also from the construction field. Now it's gonna be a residential park being built right now in Budapest. Around mid next year, it's gonna get completed. And on this side, as contractees for the general constructor, we provided a service like we call general geodesy, which is somewhat the essence of our idea. So let's say we had all the things together: field to BIM, control geodesy, main reference network, stakeout of certain critical elements on the side within the same company and within the same team. Also for the geometric control, which we would like to see now. Amongst many things, on this side we had to control the position for the concrete columns. We had to analyze the four slabs positioning and verticality, and which is also one of the most important things that occurs nowadays is the analyzation for the S-built geometry for the concrete facades for various reasons. Also, whenever the constructor who does the cast concrete in situ turns over its work and expects the payment in return, has to certify and prepare the proper documentation that the concrete structure is constructed according to the standards and the plans. Also, which is on long terms most important, that on these concrete surfaces, on the most of the occasions, there are many outer layers coming on top. And to provide the proper geometry and the position for the coming layers, like insulation or the composite covering, which is something really hot topic within the architecture nowadays. On certain occasions, when the deviations are too high and really out of tolerance, even the positioning for the consoles of these composite outer surfaces has to be readjusted and reconsidered. If this happens during the constructions, the time loss and the money loss is really really hard to calculate, because you are losing time, you do not know how much. If you can prepare and foresee this kind of critical events that might change the already existing plans, you can do the reactions in time. And even if it costs some additional work in the general time of the construction, probably you will not lose anything.
Yeah, thanks a lot, Daniel, for underlining the need and goal that are pretty many and different need and goal. And it is possible for you to describe very quickly which solution you have used on site for the scanning, and then I would immediately jump to the workflow, because I think that the time is passing, and so I really would like that you have the time to present all the success case. So can you describe a little bit, introduce which kind of technology you have used, and then we will jump to the workflow.
Exactly. So on site, now we use our Leica RTC630, again pointing out that even that we use the Faro instruments on site, it does not really matter. You just have to put it and register it in its place, and then going to Reconstructor. Also, to provide the proper geodesic network, we have our Trimble instruments. And we have all the plan data, also 2D within MicroStation in the proper place at the proper position. So our idea is, okay, we have many facets. If you have a look at the floor layouts, we got two buildings, like 3,500 and 9,500 base area from 6 to 9 floors height. It's really high. So with different like 17 and 32 different planes for the facades. And we had to control each of them. A lot of scans did in different phases. We had to extract all the proper positions from the 2D floor plans and check if the S-built state corresponds and correlates well within these standards. So what I would really like to point out again, and I really like that just by picking the two endpoints of these floor plans, these are within absolute coordinates, so georeferenced, within positioned properly within the Hungarian national grid. Just by using, please jump to the next, Georgia. Just by using these floor slab endpoints, we could just construct so-called planes and alignments in Reconstructor that we could use as a comparison basis between the plan and between the S-built states. So this is a really well-thought workflow from Reconstructor and something I really love. From really basic elements like points, you can build up planes. From the planes, you can start and just like copying and extracting the geometry from them. From one Reconstructor element, you can construct all the other Reconstructor elements, like an orthophoto from a plane, a coordinate system from the same plane. And really, from starting up from 2 points just from the facade and a point cloud, we completed the project, like the long story short. So we create a coordinate system out of each point pairs for the facade. Here you can see one example of the 17 on the smaller building. And jump the next one, please. And according to this coordinate system that we set up from the point pairs, we can also take over the case to the inspection tool and do the color deviation map. Again, we can choose the color ranging, the color distribution, however we like. We can even save the setup we do and reuse it again. Like I think I only have like 3 different color scales for my whole life, and I just import the same setups again and again. And then just to extract the data, we can do an orthophoto, like out of a plane, I can, with a few clicks, create again an orthophoto. Again, saying these orthophotos can be put back with just one script file into the proper DVG, and we are already back inside AutoCAD. And when we are back inside AutoCAD, we just use the image, which is properly positioned and scaled as a CAD underlay. So again, these kind of cast concrete structures could be inspected with a total station, 2 meters per 2 meter, but you would never have all the big image and the general overlook what happened and where might be the small out of the tolerance areas.
Yeah, I think that that's nice what you said, because of course, by using the laser scanning technology, you can keep under control a biggest area, of course, and then you can discretize and select what you would like, I mean, to keep in terms of, for example, details or something like that. But in this way, you can have a real complete overview and understanding of what is happening on a huge area and also in 3D. And the next case, I think that is also very, very interesting, because the inspection of concrete floor is something that, in my opinion, is pretty warm as topic, and the flatness report are a key requirement across engineering and construction, but also architectural design. In fact, checking the flatness in concrete floors is essential to maintaining the structural efficiency of the building, but also the safety of the building itself, and so the safety of the people. And so even the minor error could create a problem in all the operation. And so I think that the analysis of the flatness is crucial, both for the rehabilitation of existing building, but also in the new one. So Daniel, can you describe a little bit just where we are in this specific case, and which are also, which has been, or also which have been the need and goal for this case?
Okay, so from vertical now get to horizontal. Again, inside the construction industry, whenever the constructor hands over a floor, you need documentation for the actual as-built states for multiple reasons. The most important in this case, it's something crucial that on a facade, if you have a deviation, it can affect you during the construction phase. Okay, that might hurt if you miss an error. But on the floor, the deviations affect the actual use for the future. So whenever you consider a forklift going up and down with the highest speed possible to get them faster and faster, every bump you have on the concrete floor might get an amortization effect on the wheel bearings, and this is the main reason that the logistics storage companies have quite strict restrictions for the floor flatness and levelness. There are standards for this in the USA ESTM, Great Britain TR34, and in Germany the DIN. The concrete example that I'm bringing you today is also a logistic center situated around Budapest. It was like total 45,000 square meters. The actual example is going to be a department of this for 6,500 square meters, which can be surveyed within laser scanner during the day, also taking care of the proper positioning and geometric control by the classic geodetic tools. In this case, in this exact department, we use the Faro scanner, but the rest have been done with the Leica. Again, not a problem. You can choose your instrument, whatever you have. The point cloud will get into Reconstructor one day or another. The point cloud has to be classified because you have the walls, you have the columns, you have maybe the scaffolding, the reference fields in case of Faro or any other instruments that might be present during the laser scanning, and you do not want to be present within the point cloud. Also, what we have to consider is the data delivered. So again, measuring the floor within 1 or 2 per 2 meters square might be enough, but usually you will miss something. So again, you need a high resolution deviation map, because whenever an expert in this industry who can make and does this concrete industrial floors have a look on this color deviation map, will nearly immediately see the problems and can plan the solutions. Because again, whenever you have an industrial floor within with zones out of tolerances, corrigating these problems is always cheaper the sooner you can do it. If you do it in a few days after the constructions, it's easy. If you do it a bit before you hand over the area to the general contractor, it's still better than getting back in 1 year for additional costs and additional time loss.
Yeah, many thanks, Daniel, for this for this explanation about the project core, but also the workflow, the usage of the different device that has been merged. The point cloud, sorry, of this device has been merged together in Reconstructor, and also how did you pass from one software to the other? Of course, depending on what you have to do. That's pretty interesting. And I think that now we have a movie.
Exactly. So we have our own little introductory video about this whole industrial floor, just to show what to do and what happens within the site. So, well, you can recognize quite well which model did we use to create. That's a faro. We do the scanning for the whole concrete surface. We have to process and extract the proper geometric forms and the data from the raw scan data. We put it into the computer, faro scene or like a cyclone. Then we use Reconstructor, create these elevation maps. Even only the elevation maps can show quite well where are the areas out of tolerance, but we have our own development to mark these areas according to the industrial standards. And because we have the geodetic network, we can have the constructor also to mark these areas on site. So no measuring with tape, whatever, just follow the lines on the ground and go and grind it down there because it's out of the elevation. So in pretty much like this way, considering as a complete solution package, as a service, the industrial floor can get within the tolerance in time to the contracting. Okay, now a few words about the workflow. A thing which is really obvious, but not at all. Whenever you put the data inside the Reconstructor, it offers you certain type of filters for the scan data, which actually really like. Even when we do not do any kind of processing within Reconstructor, we just want to get the faro data, process it into recap or within MicroStation. We just put them into Reconstructor to roll all the feeders onto the top of them, because honestly, I think it works way better than the ones we did into faro scene or the solutions provided by Leica. So even this pre-processing dialogue is something we really like. So the basic filters like distance and reflection value, which is quite basic, but the filters provided for the edge noises, which are like a common problem, an existing one when you use the phase-based laser scanners. This kind of noises can be extracted quite well from the point cloud. Also,
Okay, I think that we have another movie. Yeah. Okay. Now I think that is visible. Okay.
okay, so one other tool we really like in Reconstructor is the way to do the coordinate systems and the transformations. So whenever someone works in the field of geodesy, we have all the national or maybe continental coordinate grids, and then we have one side coordinate system, another one, and who knows whatever. Just with the same basis as we used as an example for the facade, having just a few points extracted from AutoCAD, maybe just copy pasting the coordinates or importing them as a CSV list, you can just create a coordinate system, fit onto the geometric features in no time. So in this example, we had the whole site in the national coordinate system, and like in 2 minutes, we created within Reconstructor the transformation and the translation for the site coordinate system. And from now on, you can just jump forth and back between them, which is also really obvious, but a very powerful tool. And then the results. We have already the orthophoto, which can already be seen, the rectangles, however the concrete floor have been made during the different phases, you can identify the high points, the low points, and already according to this information, you can get a good idea where are the bumps gonna be which causing the problem. So already on looking at the map, you will know that, okay, whenever the photo has an area with the orange or reddish spots, okay, that's the places where I have to go down and smoothen the surfaces. The blue points are a bit harder to treat, but also if I smoothen the places around them, even though it's gonna be a low point, the bump is gonna come out.
Many thanks, Daniel. And I jump immediately to the latest project, which is the volume calculation in cut and fill application. I think that we have a little bit to move on this case, so we do have 5-6 minutes. I think that they will be enough for you, and then we will leave the time also for Q&A and a brief overview about all the reconstructors. So let's go immediately to the site and also the need and the goal about this project, if you could summarize them.
Okay, so we are right next to the industrial floor site, and as the providers for control geodesy, we have been asked to calculate the cubature for one of the earth depots next to the site, which is quite an easy task whenever you are not situated right next to the main airport of Budapest, because then it means that this is a no-drone zone. So you will not fly at any cost. Also, you cannot climb onto the stockpiles because the soil is unstable and you would fall by and suffer an accident, which is also something we would like to avoid at any cost. So classical geodesy methods are also out of the question. Okay, so terrestrial laser scanning. Again, we had the Leica RTC 630 again in this site, and we can just put all the data after doing the registration within the Reconstructor. If we have all the vegetation and the external noise filtered out of the point cloud, we can use this as a good basis to create a thin model from the surface and the mesh, which we can compare just by a 2-click with one of the built-in tools of Reconstructor. Also an interesting case that the previous measurement have been provided by another contracted by the constructor of this area, so we do not have our own data set to compare. We had to take it out from a 2.5D line drawing within AutoCAD. But no problem, you can just construct a mesh out of it, and the two meshes with the proper tool of Reconstructor, which is called cut and fill. You can see the previous state on the left side, you can see the external state on the right side. You can just 1-click align the two meshes on top of each other, and with one button, please tell me, Reconstructor, how many cubic meters do we have above and below the previous state. Also, just not to leave the inspection tool out of the story, we can compare the two data sets. Okay, whenever I have an area taller, which have been changed positively, I can give it a color accordingly. Or the sites where the earth have been digged out of the previous depot, I can align and follow quite well and visually that the data have been extracted from there.
Many thanks, Daniel, also for this case, because we enter also in another application, which is the mesh creation, of course, the DTM creation for the volume computation, and also how it is possible to compare models and to calculate the volume, and also again to create this colorization map. So many thanks also for that. I will pass very fast on some reconstructor characteristic, which are the possibility to integrate different data inside the reconstructor, as Daniel completely described in the success case experience. but also the possibility to exit from Reconstructor in third-party software, independence on the industry field where you are working. For example, you could go inside a software specific for mining or construction, or even for digital twin to share your data on cloud-based platform. As Daniel underlined pretty well, Reconstructor is pretty appreciated because it's a multi-resolution platform. So you can really put inside different kind of data, which could be point cloud coming from different sources, even mesh, polyline, images, points as coordinates, and you can merge all the data together. And Reconstructor can provide a complete workflow for the data management. And of course, the workflow that Daniel so clearly described today is inside the main core of the software, which is Reconstructor. But you can enrich the Reconstructor usage also with two specific add-on, the color add-on, that allows you to enrich the quality of the point cloud in terms of texture, because you can use external pictures to reproject high resolution details on the point cloud and also on the meshes. And you can even use these pictures to create high resolution texturized model. And then the mining tool that Daniel described in the latest success case, experiencing the creation of the topographic mesh, the volume computation, and the cut and fill. So we can say that Reconstructor has a little bit for everyone. And before jump to the Q&A session, we'd like to, of course, we do have also specific packages in Reconstructor for the Aeron mobile mapping system, which can help you in getting faster in your job. And before going now to the Q&A session, I would like to introduce the special proposal that we have set up for you as a Christmas gift. So if you would like to experience the Reconstructor usage, the tools that Daniel has so clearly introduced to you and explained to you, you can benefit of this special Christmas gift, by which you can use Reconstructor, the color add-on and the mining add-on for 3 months at a special price. You don't have any kind of limitation in terms of data import, data export, deliverables creation. The only limitation that you have is in the timing, okay, of the license. If you would like to know more, you can visit our web store, okay, and then you can jump directly inside the Reconstructor world. Of course, this proposal is limited up to the 7th of December. So now, let me really thanks a lot you, Daniel, and also Geolink, all the team of Geolink. So pretty thank you very much for being with us today and to have describe and make us gave us the possibility to experience how to work in different industry field with different needs, different goals, but also different difficulties, of course, as you underline. And I think that now we have some minutes for the Q&A session. So we can immediately jump to the Q&A session. Daniel, I have a question for you, if it is possible. When you describe the success case related to the facade inspection, did you make this comparison only based on 3D models, or did you compare also the existing CAD models with what you scan? So the comparison has been done comparing 3D models or also comparing the 2D DVG file?
In this case, the situation is like this. So we had the 2D DVG file used as a basis, and then we built up our Reconstructor system accordingly like this, like from points. But also, nowadays we are changing our workflow. And in our recent projects, we build the CAD surface model in 3D within MicroStation, take out the 3D model as a mesh, which might be a mesh or you can even take in an IFC file from Revit, from Tekla, from whatever BIM software you can use. Have this model within, like different facets, different shapes, not just planar and vertical, but any kind that the architectural designers can dream about. And just comparing the point cloud with the inspection within one click, you can get out to the same results.
Okay, many thanks for this for replying. And someone is asking if it is possible to export to Recap. Yeah, it is. It is possible. Reconstructor has a direct exportation to Recap. You can move normally, yeah, it's point cloud, which related also it's a panorama picture, and so you can enter directly inside Recap, exporting in RCP format. Other are asking if it's possible to create mesh. Yeah, as Daniel explained, it is possible to create meshes in Reconstructor. We experience with Daniel the possibility to create what we call topographic mesh, mainly for mining application. But of course, we also provide, sorry, the software provide different other different tools to create the meshes, like for example multi-resolution mesh or mesh for a tank or a small object or tunneling. Other question is if it is possible to export in DXF. Yes, it is possible. You can export both 2D polyline in DXF, and because in Reconstructor you can create sections, so you can export these section in DXF, and even mesh. Even the mesh that you create can be exported in DXF. In DXF. Daniel, someone is asking, how did you take to learn pretty good the software, if it is easy or not? I will leave you replying on that, of course.
Well, as Georgia mentioned, we have been in contact for 9 years. That's a long time to learn something. But just returning back on the serious ground, this new inspection project that I have been mentioning in the previous question is being done by a colleague who's working with us for 2 weeks now, just by showing him the basic processes. So I think comparing to different softwares that we use out on the field, like I think no one ever existed who knew AutoCAD or Microsoft Excel in depth in his whole life. Then compared to this, Reconstructor, I think is quite well built, quite clearly constructed, and well organized software. That's something that I can honestly say.
Okay, many thanks, and there's another question, I think. Can we import raw data scans and align in Reconstructor? I think that, Daniel, we can also reply together. Yes, you can import some raw data inside Reconstructor, and you can align the data in Reconstructor. We do have different registration possibility, target-less registration, target-based registration, manual registration. But what I think it's nice is that, of course, you can do all this registration process in Reconstructor, also importing raw data. But for any kind of reason, if you do have to use other software, which Daniel mentioned, like Pharocene or Cyclone, or there are so other software, what is nice is that you can use those software to pre-register or even register the scan, import all this data inside Reconstructor, and then you can merge this data together in Reconstructor. And this is one, I think, of the common feature that we found in Daniel's project, right? This is also how you work, Daniel, right? Also using our software to other software to pre-register scans, import then the scans, and align them in Reconstructor, or vice versa. You can import directly raw data and then align from zero all that data. It really depends, I think, on what you have to do, right?
Exactly. So we do what you have explained, and also to press a bit more on this topic, we can use data captured by UAV, or we even have experience from the past using multi-beam echo sounder data within Reconstructor. So for example, that's also a live topic we have right now, churches. So the inside, the tower, you can do with the TLS, you can register within Reconstructor, or if you have the software provided for the manufacturer, Spharocene, Cyclone, Realworks, you can do it there. But also, for example, if you have a UAV unstructured data from Agisoft, from Pix4D, context capture, or all the industry leading softwares, you can export that data in any kind of common formats, 57, LAS, or whatever kind of point cloud inter-exchange format you can export. Take it into Reconstructor and do a bundle alignment, it's called. So find me the best adjustment between the 2 point clouds. Does the upper parts of the church's tower, for example, or the roofs, not just for churches, but for any kind of commercial buildings, can be aligned the best way possible that you can achieve from the two instruments dataset combination.
Yeah, many thanks, Daniel. Many thanks also to have underlined the capability to manage also this UAV data. Of course, already pre-processing is Agisoft or Reality Capture or Pix4D or 3D Zephyr or other kind of photogrammetric software, but it is pretty something that people pretty like, the possibility to put in one single software platform, different kind of data, and then merge all this data together and then create a single point cloud in a sort of clever way, because in Reconstructor is possible, and I am replying also to another question, which is it is possible to create one single point cloud, putting together different cloud coming from different sensors. Yeah, it is possible, and we do have two possibilities, just making a very quick and simple cluster, okay, just clustering the point cloud. But what people like is that we do have a nice tool which is called volumetric filters, by which you can create, starting from point cloud coming from different sources, and so with the different resolution, you can create a new point cloud with a regular resolution. And this is pretty nice if you are working, as Daniel mentioned, with, for example, a data coming from UAV, and then a data coming from static laser scanning. And so you want at the end to create one single point cloud with a uniform resolution. So thanks for the question. I think that we have finished today's time. Don't worry, Guy, because of course, if we do have other question, doubt, curiosity, you can always contact me and Daniel. We will be pretty pleased to provide further details. Before leaving, do not forget to follow us on Facebook, LinkedIn, and also Instagram, so that you can also be updated about what we are going to do next event, conference, next webinar. We will upload the today's movie shortly, okay, so you will receive an email in the incoming days with the record of the session. I'd like to thanks again at first Daniel and the friend from GeoLink 3D. Really thank you very much for your time and the possibility to experience with us this success case. I'd like also to thank all of our attendees for being with us till now. And thanks a lot, Daniel, again. Pretty appreciate.
Thank you again for the opportunity, and I wish a nice and pleasant afternoon and evening for all the attendees.
Thanks a lot. Hi, guys, and just stay tuned for the next webinar. Bye.